Hey guys, this video is going to review 10.3, 10.4, and 10.5. So 10.3 states, what are all the things we notice about chords? So as we read through here, chords have their endpoints on the circle. This means that they end up creating radiuses or radii. So oftentimes we draw in their radiuses to create triangles, and this helps us use Pythagorean theorems. So if we look here in this example, they identified this triangle where the small side was 3, the medium side was not 14, but we notice that the chords get cut in half at a 90-degree angle. So that's a perpendicular bisector. And we've had perpendicular bisectors actually on and off all year. So this would split that into 2 equal pieces. So see why they ended up putting not the number 14, but the number 7. Okay, so this is how they ended up solving for the hypotenuse. I'll just call that x. And they called it BT. Either way is fine. And they ended up doing a little math, and they ended up finding it was 7.6. And that makes sense. We were looking for a number greater than 7 and greater than 3, because the hypotenuse is the longest side. Now taking a look at our examples here, we notice a lot of perpendicular bisectors. We also notice some information about this arc length. They're telling us this arc length is 44, which tells me this angle is 44. If this is 90, I can solve for that missing angle, right? If the whole triangle adds up to 180, then I take away the 90, take away the 44, I end up getting 46 degrees. Okay, so that's interesting. Notice the same should, if this distance and this distance are equal, this would have had to have been 44. This is 44. This is 46. A lot of information happens to just kind of fall out of the sky because we've got two twin triangles. Now here, they also tell us that the radius is 7. So when we think about this, this is a radius, but not that whole radius, just this part is 5. Thinking as well, this is 7, this is 7, this is 7, this is 7. All those are 7. So I can put a 7 here, and this helps me draw attention to this other triangle here, right? Which I know is the twin to this triangle. So I can solve for, what all do they want me to solve for? Yeah, these are, if these are all equal to each other, all these 4 triangles here are all equal as well. So if this is 5, this also would be 5. So could we solve for what's left here? Yes, we could. That would have to be 2, because if the whole thing's 7 and 5 is left here, then there's got to be 2 sticking out. What about CD? Well, we can actually use this triangle to solve for this length, and then we'll know all 4 lengths with that marking have the same length. So let's call that x. So we have x squared plus our 5 squared is equal to our hypotenuse, 7 squared. So what is all of these things, really? This length is the square root of 24. This length is the square root of 24. This length is the square root of 4. All those lengths are the square root of 24. So they want to know what's this whole length. So that would be the square root of 24 plus another square root of 24, which would be 2 square roots of 24. Now, let's say you did that, but that wasn't one of your choices on the test. Well, you're like, well, there's a 4 in there, right? So this is the same as the square root of 6, or I actually like to put it the other direction. Square root of 4 times the square root of 6, so it's 2 times the square root of 6. So technically CD is 2 times the square root of 6 plus another 2 times the square root of 6. So that's 4 times the square root of 6. And then if that's your answer, these are actually equivalent. If they ask for a decimal, no problem. What's the square root of 24? So the square root of 24 is 4.9. And so if each of these, and that's a number that makes sense, that's 4.9. So this was 4.9 and that's 4.9. So if we add them together, we get about 9.8. Okay? So whether it's an exact answer or a decimal, we're prepared for any type of question. Now let's try to answer BTA. So BTA. Okay, that looks like it'd be 2 44s. So 2 44s make 88 degrees. Nice. Okay, number 18. It says circle T and S intersect at points A and B. So let's draw a picture of what they're describing here. I'm gonna give myself a little bit of room. All right, so I don't necessarily know they're the same size circle. It looks like one of my circles looks slightly bigger than the other, but okay, so two circles, T and S, intersect at points A and B. Okay. What is the relationship between the line segment AB and TS? Those are perpendicular bisectors, aren't they? Definitely AB gets cut in half. AB and let me use this. AB would have to be perpendicular to TS, and AB is cut in half, right? It's a perpendicular bisector. Okay, 19, that was an interesting question. Contractor cuts off part of a circular countertop. So it used to look all the way of a circle, and then they cut that part off, maybe to push it against a wall or something. Yeah, to fit against a wall. What should be the length of X? Okay, so that's really our chord length. So they're asking, what is the length of our chord? And if we find the middle of our circle here, we can extend a radius and figure this out. So this is like our fishbowl problem we did in class. Very cool, right? We know that if all the way across is 120, then if we divide by 2, then any radius in this circle has to be 60. That's 60. That's 60. This is 60. So what we're really doing is solving, and I'm going to call this y because I want to solve for this. I really want to know what y is. Right here in a second, and I think I can find that out because y and 60, the whole length of the table after he's cut it, was told to us it's 100. So now as we think of this, we say to ourselves, y would have to be 40. So as we walk, well, no, maybe I want to leave that there. So as we walk this back here, let me get a smaller eraser. We think, oh, that actually has to be 40. Okay, so I have an equilateral triangle, and I'm going to call this Z. I already used the letter X, I already used the Y, so I'm going to use a new letter. If I know what Z is, then to find X, I'm just going to double it. Okay, and I can use, oh, and that kind of looks like the most famous triangle of all time. Maybe not, no, okay. So let's do it. It says one of our sides is Z, so I'll do Z squared. One side is 40, 40 squared. And that has to use equal or hypotenuse squared. So Z is the square root of 2,000. It does say round to the nearest tenth, so I'm going to round anyway, so I might as well turn it into a decimal now. So the square root of 2,000 is 44.72. So we have this is equal to 44.72, and this is another 44.72 because those are congruent. So X is equal to 2 times 44.72. right? So times 2. So I'm going to do 89.4 because I'm going to round to the nearest tenth. Now let's see if that makes sense. If this is 100, does that make sense that that's 80, 90 something? I think that sounds pretty reasonable. So section 10.3 done. Okay, my last 2 sections I love. These are some of my favorite problems all year. So let's dig in. We have an arc length and an arc length, and we can solve for this missing arc length because they all have to add up to 360. It doesn't look like they did this problem this way, but when I kind of read a problem, I like to fill in anything I could solve for. So I take 360, take away 116. I get 244, and then take away an 84, and I get 160. Okay, so now this is kind of, I pretty much know everything. It says, what is the angle measurement of A, B, C? Well, the tip of the cone is half the snow, 80. Notice we came to the same answer, but used a different method. So what method did they use? Well, I'll use a red pen to show the method they used. They said, okay, if the arc length is 84, half of that tip of the cone is half the snow. If this arc length is 116, half of that would be 58. Then they use the triangle sum theorem to figure out 80 would be left over. Either way, you get the answer 80. So if you are watching the video and you already worked questions 20 through 24, don't erase your work. You could have used a different method, but still got the same answer as I did. And that's the exciting part about mathematics. So here, our tip of the cone, right, here's our first cone, right, is half the snow. Okay, so we don't know what that snow is, but, you know, it looks about 90. So then this angle would be 45, right? And then we look at a different snow cone. The tip of this cone is half of this snow. So, wow, okay, that has to be the same number. So this has to be half of whatever this is. This has to be half of whatever this is. So these two have to be equal to each other. It's kind of a transitive logic. So we're going to set these equal and solve. So I got 9x minus 6 has to equal 5x plus 14. So we subtract 5x on both sides. And then add 6 on both sides. And then divide by 4, and we get 5. X is 5, so plugging x in for 5. 5 times 5 plus 14. I get 39. And let's plug in 5 here. 9 times 5 minus 6. 39. And that's what we were hoping for. So what is the arc length? The tip of the cone is half the snow. So I got to do 39. Actually, let's do it down here. I got to multiply by 2. So that'd be 18, 6, 7, 78. This is 78. The tip of that cone is half, 39. The tip of this cone is half, 39. All right. What do we have here next? Okay, so they said this angle is 51. This angle is 90. That's a straight, this tangent line is straight. It has to add up to 180. So I think we can find this little angle in there. 180 minus 90 minus 51. So this angle has to be 39. Okay. What else do we know? Okay, kind of this, if this angle is 90, then if I extend this line here, this is the arc bound by that. I'm not sure that's telling me anything. If this angle is 51, then this snow has to be double that. So 51 times 2 is 102. This has to be 102. Interesting, they told us this arc is 163, excuse me. And so how much arc do we have left over? Because all the way around is 360. right? Is it 360? Take away 163, 197, take away 102. We get 95. Okay, so that's 95. What is the measure of angle MNP? MNP. So this snow is 95, and the tip of the cone is half the snow. So I've got to divide 95 in half. So 95 divided by 2 is, so this angle would be 47 and a half. 47 and a half. So this arc length was 78, just to keep track of everything. All right, 22. We have a little bit of a shortcut, right? If we have a circle trapped, then we know opposite angles are supplements. These two have to be supplements, meaning if I add them together, they have to add up to 180. So that gives me 15x. If I divide by 15, I don't want to divide by 15x, just divide by 15. 180 divided by 15 is 12. Okay, so there's a lot. This circle feels a little too tight for me, so I'm just going to redraw this. You don't have to, but for my mental stability here, I feel the need. All right, so if x is 12, 6 times 12 is 72. So this is 72. 9 times 12 is 108. Yeah, and those add up to 180. So x would be still 12. So 8 times 12 plus 5 is 96 plus 5. So that'd be 101. And we just have one angle left over. So all those have to add up to 360. So you can take 360, take away 72, take away 101, take away 108. Let's see what's left over in our calculator. Oh, or you could go faster. You know, these two have to add up to 180. So just 180 minus 101. Yeah, that's a little, either way would work. Doesn't matter. 79. Cool. So this angle is 79 degrees. 23. 23 gives us a triangle, so I'm going to just go ahead and solve for that missing one. 180, take away 71, take away 59 in our calculator. And we get 50. Okay, that's 50. So tip of the cone is half the snow. That makes this snow 100. That makes that angle back to 50. Tip of the cone is half the snow. These are vertical angles, so that's 71. So notice what's happened, 50, 71, that forces this angle has to be 59. That's what's left over from 180. So which angle do they want? QPR, QPR. It looks like they want this angle, which we know is 50. Now 24 says, let's generalize. If a rectangle is trapped inside of a circle, much must be true about the diagonals of the rectangle. Well, that's kind of tying together the last chapter. So if we trap a rectangle, right, saying these are equal and these are all 90, what is true about our diagonals? A diagonal and a diagonal. We knew quads that rectangles have equal diagonals, but notice here our diagonals are diameters, and they're equal in length. So if we called this rectangle ABCD, we can say AC is congruent to BD. That's true for any rectangle. And we can say the diagonals AC and BD are diagonals and are diameters and chords. Okay, 10-5. We notice here, and I talked about this in class, it's like the part on the outside, 6. times the whole thing, 6 plus 12, has to equal the part on the outside, 4 times the whole thing, 4 plus x. And that's how we set it up and solve. So I'm going to go ahead and do the same thing here. The part on the outside, 8 times the whole thing, 8 plus 10. Has to equal the part on the outside, whatever that is, WZ, I'll just call it X, times the whole thing, well, that's the whole thing. So X times X, or X squared. So here we have 8, 8 times 18. So 8 times 18 is 144. Ooh, we got lucky. The square root of 144 is 12. So if we plug this back in, we notice 8 times 18 is 144 and 12 times 12 is 144. So definitely our length of WZ is 12 units long. Now let's look at our arcs. No, let's finish our lengths. So segment lengths. So in our notes, we have these segments. We could call that X. So when the angle's exterior, it's the part on the outside times the whole thing is equal to the part on the outside times the whole thing. Our other formula looks something like this, like top times bottom is equal to left times the right, something like that, right? So we can say 10 times X is equal to 5 times 12. So that'd be 60. And so X has to be 6. When we plug this in, we notice that 6 times 10 is 60 and 5 times 12 is 60. Okay, now switching to angles. So our angles and arcs formulas is either, if the angle's inside, we're going to find the average, right? I'm going to take 81 and 43, add them together, and divide by 2. That's the average. 43 and 81, and then cut that in half, 62. In RP, yep, that'd be 62. And notice we're looking for a number between 43 and 81, and we got it. Now the other formula is, instead of add the 2, we subtract. So we take the big arc, 189, minus the little arc. This would be XC's, so we can call that Y, because it looks like I've already used the letter X, so we'll call that Y. Big arc minus little arc, and then we'll cut that in half. And it has to equal the angle on the outsides. Well, they already gave us it has to equal this angle 74. So we've got to do a little bit of algebra. All right, so I've got a 2. I'd like to kind of lynch swap, move that up there, right? So 74 times 2, 148. And a couple ways to do this. I'm going to add Y on both sides, get it over here. And then subtract 148, kind of running out of here. So Y is 187 minus 148, 39. Beautiful. So we can double check this is 187 minus 39, 187 minus 39, which is 148. And when we cut that in half, do we get 74? Yes, we do get 74. So we feel good about our answer. Our arc length is 39. Last question. A student said that if angle A is formed by 2 secants, so where do I have a little bit of room here to write this? If angle A is formed by 2 secants and it's intersecting outside of a circle, then angle A has to be less than 90. Do you agree? Okay, so they're saying this is called angle A. This is a secant because it's got to go in and out twice. So each of those are secants. It has to be less than 90. And we notice by drawing this, I think we would have to agree. If we try to make angle A too big, even as big as possible and turn these into tangents, that's still an acute angle. So I think, do you agree, explain? Yes, agree. Because, now we can say with our pictures, see drawings, because there's no way to draw two secants without the angle being acute. All right, nice work, guys.